Alright, we are going to mix up some paint. So I'm in the color software. I'm going to click color formulas. And I'm just going to look up a car instead of using a code. I'll show you the two different ways that we do this. So the color I'm looking for is the Subaru's come in this like super bright orange. I'm going to pick Subaru. I don't know what the code is. I just know I want that Subaru bright orange. It's on the little crossover ones. I'm going to say they came out in like 2014. The application is the exterior because the outside is orange. And the model is, it's not the Impreza. It's like the XT, the little SUV one. And we'll look it up in solvent paint. Color name, this should find it. Let's see. No formula found. Subaru 2014 exterior. Oh no, it's not an XT. What is it called? XV? The XT is like that super old, weird. Nope, it's not that either. What are those things called? XT, SVX, SV Crosstrek. Maybe this is it. Yeah, okay. Oh, there it is. Tangerine orange. That's the one we want. And we'll mix up this one. So you get alternates. So this is two different alternates for the same color code. This one says it's the same as the color chip, and this one was probably a modification by a painter. And it says this one is a match to a 2015 XV Crosstrek. So this actual car wasn't quite the same as the paint chip. So we'll try this one just for fun. We're going to activate the paint. And this is the formula. And then the formula with the reduction. So we're going to mix up just a little bit so we're not wasting too much money. Size that, oh wait, I gotta go one more tick. So it's not red. You need the warning to go away. Because what happens is these smaller ones like the bright fine aluminum or the low strength black might be very, very small amounts of paint in the formula. So you'd have to put in like less than a drop. So we can't mix less than 10 ounces. So we're gonna have to mix 10 ounces in order for the color to be correct. So click OK. Whoops, reduction only on formula and reduction. There we go. That's the whole thing, the whole recipe for us to make this paint. I'm going to click print, and it'll give us the little recipe card down here. So we can go and print it, and it looks like this. Okay. So now we go and mix it on the scale. Okay, in the mix room, we have to mix the paint. All these little guys have to stir. They have a little propeller inside there that agitates the paint so that it's mixed thoroughly and the color will be accurate all the way through. We don't have to listen to this though because I already mixed it. So we're gonna go over to the scale. We're gonna start. This is what I like to do, is I like to just stick it to the scale like this. Okay, and I got a little mix cup. We're going to set this on the scale, and then when we set that on the scale, the cup weighs 19 grams with nothing on there. Well, with nothing on there, it weighs nothing. This little cup weighs 17.5 grams. So what we have to do is delete the cup, because this recipe is only taking into account the paint, so we need the cup to weigh nothing. So we do what's called tearing the scale. So we tear it, and now the cup, we tear it, it's very sensitive. If I do just talking, makes it fluctuate. If I just blow, can measure my coffee breath, you know. Okay, so the cup weighs nothing. The scale is tared, meaning it's only going to weigh the paint now. Okay, so what we have to do, if you look at the little recipe card, we have to get all of these toners, and they're all different tints, different colors that you mix together to make this tangerine orange. So SBL 81 is this can here, which is high strength yellow oxide. And instead of, like normally what I do is I just go to the machine and pick them off one by one and bring them. But so you guys don't have to watch me go back and forth a million times to get cans. I just put them all out here so they're ready to go in a line, right? So this is the first one that goes in. They're all stirred up, and we need 29 point, we need this to read 0. We need 29.9 grams. So we're going to fill this up to 29.9. So when you get close, you got to slow down. When you get really close, you just want to go drip for drip. Right there, 29.9, so that's the perfect amount of high strength yellow oxide. Okay, so that one is done. So we'll put it over there. The next one is 53. This one is red orange, and we need to go to 50.3. So these formulas have two lines on them. The first line is the cumulative line. So this is 29 plus 20.4 equals 50.3. So this one, instead of resetting the scale in between every single color, you just go down here and eventually we end up with 346 grams of paint, right? But if you want to, if you have a problem or if you make a mistake or something like that, you can switch over and put the individuals in, right? So why we had to mix up so much paint, we can see right now, this SBL 19, there's only 0.8 grams in there, right? So it's a very small amount. So it'd start to affect the color accuracy, right? So this one we're gonna go to 50.3. 50.3, and I have a terrible memory, so I have to remind myself constantly what I'm doing. Just filling this to 50.3. And I'm getting close, so I'm going to put it in drop by drop. 50.2, one more drop. Oh, one more drop. One more drop. 50.3. Okay? And you can see now that reddy orange color in there. So the next one is 18. This is 18. And this one is brightness adjuster. So this is just clear goop. And this one we have to put 56.7. 56.7. 56.7, 56.7, a little bit more, a little bit more. There we go, 56.7. Okay, next one is 01. We got 01. Oh, this one is very full and it's white. And we're going to put in of white 59.7. So it's not very much with a very, very big can. 59.7. Ugh. 59.7. 9.1, 2, 3, 4, 5, 6, 7. One more drip. Come on. Ugh. 7. Okay. So that one's done. Now we're on to 64. 64 is magenta. So now we're putting purple into our orange paint. Interesting, interesting. 59. Now we need to go 62.6. 62.6. 62.6, 62.6, 62.6, 62. 0.1, 0.2, 0.3, 0.4. Oh, shut off. The thing's a little stuck. Easy. 6. Okay, that one's done. Next one is was 60. This was 64, so we're on 7. 7 is black. Low strength. LS stands for low strength, so it's not as strong as the full strength black. Okay, so this one is 63.7. So not very much of this in there. 63.1, 2, 3, 4, 5, 7. Oh, that's close. Why is most of this recipe ends in 7s for some reason? And then we got 19, and it is bright fine aluminum, which I didn't think that was a metallic color. The aluminums in these solvent systems have a tendency to go really goopy like this, so sometimes you gotta clean the lid out. So I'm gonna go and clean this lid out. Okay, lid is clean. And I'm not too sure why, but the aluminum colors, the silvers, always go bad first, and they're always thicker, and they just like thicken up until you can't use them anymore. The shelf life of the product is, I think, 2 years once opened, and these things, they die in 2 years. I think this is why it's set to 2 years. So it'll be a little goopy, but once it gets in with the other toners and we stir it up, the solvents will remelt it and we'll be good. So we got 63.7, 64.5. So we're gonna go 64.5 with this one. 64.5, and I'm gonna go over a little bit just to show you guys. 0.6. So if you go over, what I always do is I pour right in the middle of the cup, right? So if you go over by a little bit, you can actually just grab just the silver, and you just use like a little corner of paper towel, or in this case, can opener, whatever, and you can pull it out and correct it, right? And if you look at the thing, there's only silver on there, so I didn't mess up the color. I just drew out my 0.1, my 1/10 of a gram of silver that I went over on, right? So that's that one done. Now we gotta go to 626B, which is more clear stuff. This is an integration binder. The integration binder, 77.7. 2, 4, 5, 6, 7. Oops, 8, 9. Oh well, this shouldn't affect the color because it's not a color, it's just the binder, right? So 0.2 and the binder won't do anything, but if you do something like this and it's not going to affect the color, the same thing would be with like that 25B or the 6627. It's like the clear stuff that's in there, it doesn't mess up the color. So I'm over by 2.2, 2/10 of a gram. So what I'm going to do now, I'm on SBL T25B. I'm going to hit 0. And now I'm not going to do the accumulative anymore. I'm going to do the individual. So I know 25B, I need 22.4 of this stuff put in there. So this is the 25B. I'm going to put 22.4 in, and we're still going to be good, and we'll have an accurate tangerine orange. 22.4, 22.4, 22.4, a little tiny bit more. And again, if you went over by a couple tenths or whatever with this stuff, it wouldn't really matter either anyway. So that is the actual paint done, and you can see all the different layers of colors we put in there. And when we stir this up, it should turn into tangerine orange that's on those little Subaru SUVs. and it should look like a tangerine. So you can see it's red. Now some of the yellow, orangey stuff is coming up. And as we stir it, it should turn into that tangerine color, unless I made a mistake somewhere. And it takes a while because those little toners are kind of sticky, right? Okay, and that's the orange that's on those little Subarus, right? Okay, anything else we have to do? So one thing that happened, right? So that was 22.4, now we got 21.4. So there's a gram of paint just stuck to this, this stir stick, right? So one of the things that we're gonna have to do is, this is the reduction now, right? 6627, and I'm gonna show you guys how to do that once I clean this stick, because we can't use the scale anymore because all the paint's not in there. I took some out, so this recipe's kind of messed up. So I could put in the 236.1 of the reducer, but that's not actually perfectly accurate because some of the paint's out of there. I splashed some on my glove. It's all up on the sides of the cup and stuff. So now we're gonna go away from the scale, and we're gonna mix by volume following the tech sheet, okay? Okay, so this is the technical data sheet for the base coat, right? And it says the mix ratio of that 6627, so you could pick 65 or 6665, 6627, or 6629, depending on the temperature. We're using 6627, so the booth will be set at 74 or 24 degrees Celsius, like room temperature is for normal temperature, right? 29 is for when it's hot out. 65 is when it's colder, right? So, and it says you can mix it up 1 to 2, means 1 volume of paint to 2 volumes of this application adjustment binder, what we call it the reducer, although it's more than just a reducer, but this is the reduction process, right? So the reducer for this stuff has a binder in it as well, right? So this paint does have some binder in it, but if you painted it like this, it would just peel off of the clear coat like crazy because it doesn't have like the glue that holds it all together, right? So 2 to 1. 2 to 1 can be expressed as 1/3, right? Because if you put 1 plus 2 equals 3, so 1/3 of it is actually paint. This can also be done as a percentage. So if the paint is 100%, because that's 100% of the paint mix, it's 200% reduction, right? So you put 200% more in it to reduce it down, right? So that's what we have to do, and there's 2 ways that we can do it. So the mix cups tend to have scales printed on them, and you see them from the inside of the cup. So there's a 2 to 1. And there's a 3 to 1, but they don't come, this is kind of a bit weird for it to be so highly reduced. So 2 to 1 is very, very common. 1 to 2 is not. It's like the exact opposite, right? So this 2 to 1 would be 2/3 paint to 1/3 reducer. This one is 1 to 2, so it's 1/3 paint to 2/3 reducer. You wouldn't want to mix that up or screw it up, right? So we can't use that scale, but what we can use is the numbers on the side, right? So if it was, say, filled to 4, if we filled it to 8, it'd be 100% reduction, right? It'd be 1 to 1. If we filled it to 4, then it'd be 8, 9, 10, 11, 12. We'd have to fill to 12. The cup would be overflowing. Actually, I don't even know if all this is going to fit in here, but we'll find out. It might be right to the rim, right? Or we could use the side here. So say there's 100 milliliters. We would just fill it to 300 millimeters. But because I stirred the paint, all the sides are all messed up now and I can't see. So I'm going to use this mix stick, which does the same thing. It shows the graduations just on the stick. Okay, and I'm going to tell you, I'm going to do this, but I'm going to tell you why it's wrong afterwards, right? So this 2 to 1 ratio is the wrong one, right? Because that's 2 parts paint to 1 part reducer. So I need to go to this side, 2 to 1, 2 to 1 to 1, which would be like a paint then an hardener or a activator, and then a reducer. We want the 1 to 2. So you can see a little tiny bit of paint, humongous amount of reducer on this stick, right? So I'm going to plop this guy in here, and it'll be like having the clean side of the cup, right? And as you can see, it's pretty much right at the 1, so I just got to go to the 3, and then I'm good to go, right? And it's actually okay for this paint scale to be on an angle. It doesn't matter if it's standing up or laying down or whatever, as long as you don't change that angle, because what we're doing is a ratio, right? So all we have to make sure is that that 100% gets 200% on top of it, right? The 1/3 and then the 2/3 on top. So it doesn't matter what angle the stick is on, but I'll tell you what does matter afterwards, right? So what I'm going to do is fill this up with the application adjustment binder to the 3, and there's our paint, right? And it's kind of crazy when you think about it, how little paint color turned into how much actual paint, right? Because some of the stuff, well, 3 of the cans that we entered in this recipe were just clear and had no color in it. The pigments are very highly concentrated. The clear stuff is like the actual paint, right? The colors are just what give it its color, but you could remove all those colors and just put in whatever the application adjustment binder one was, and the 6626B and the 25 and all that stuff, and you basically have like clear paint with no color in it, right? And to show you that, this is mosaic paint that was mixed up a while ago, and you can see how little of it. So even if it was 2 to, so it would be like 1, 2, so this was the original paint, and then that was the reduction, 1, 2 on top. So the 1 to 2, right? And you can see that all the clear stuff is settled in this just from it sitting here during the quarantine. And that's the actual pigment, the stuff that is the white of this white paint. The rest of it is the paint reduction, binders and resins and stuff that actually make up the sprayable paint. This is just the color sitting in the bottom. And that's basically what we did, but with an orange instead of a white, except this is stirred up. So if I stirred that, it would turn into white paint again, right? So that's it. But now I'm going to explain what's actually wrong about what I did with that mix stick, because it's not entirely correct. Okay, so it'll be close enough. We'll get the job done, but technically incorrect. So I'm going to wipe this down, and I'm just going to show you something on this scale, right? So these little cups, they stack onto each other, right? So any cup that stacks like this, you cannot use a mix stick in. I'm going to explain why, right? And it's because I'm going to get down here and hold the camera like that, and I'm going to show you this cup is not straight, right? It's called a tapered cup. So like a Tim Hortons cup or a paint mix cup. And why the mix stick is actually silk screened onto the side of this cup is because of this reason, right? The bottom of this cup is smaller than the top of this cup, right? So you'd be going, well, what does that matter? Well, if I put this up, so I did the 1 to 2 to 3, so there's 1 is paint, and then 2 and 3 is the reducer. The problem is the bottom of the cup is smaller than the top of the cup, so I've actually over reduced this stuff. I put too much of that 6627 into this cup because the top of the cup is bigger, right? And if you actually look at it, if you divide this cup in half for the 2 to the 4 right to the top, you can see the top is actually substantially bigger, right? Because the bottom, there's about 1 centimeter there in diameter, so it's 2 centimeters in the radius smaller than the top of the cup is, right? So there's actually, like expressed as a percentage, it's probably about 15% bigger on the top than it is on the bottom. So you're going to be over putting stuff in when you use this inside that cup, right? The only way you can use these mix sticks is if it's like a cylinder, and you can buy these cans like actual paint can, a metal paint can, or you can buy these cardboard cylindrical cans. They don't stack into each other. They come in a big cardboard box. Then you can use a mix stick, right? You have to use the mix that's on the side of this cup. So any cup that stacks is no good, right? So if I look at the side of this, what I should have done is use this graduation on the side. It probably would have been at the 3. So then I would go with the reducer. I go 1, 2, 3 for the 1 to 1, and then 1, 2, 3 for the 1 to 2, and it would have been filled up to the 9, right? So that's if it actually had that much paint in it, right? Or you could use any of the numbers on here that it lined up with, and just on the same column, just go up 2 more, and it would have worked without messing it up, right? So this isn't actually mixed correctly because I put too much of that stuff in because the top of the cup is too big, right? So it's a simple mistake that a lot of people never really thought to think about, and many painters actually do this incorrectly. So there's another thing that I'm going to show you too, is if you look at that, so it's 100 and then 336, right? So you would go in your head, well, if it's 1 to 2, then this should be 100, and then there should be 200 on top of it, right? But it's 236. So what the heck is going on with that? Well, the problem with that is weight and volume have no relation to each other whatsoever. And it's because every liquid has a different specific gravity, right? It's like filling this container up to the brim, just like this one's filled up to the brim, with, I don't know, let's say aluminum, and then filling that one up with lead, right? And they're the same volume, like on a mix stick, but they weigh different amounts, right? So imagine I fill this one up with feathers, and that one I fill up with rocks, right? It's not going to be the same weight, and I'll show you. So this is a clear liquid, that's a clear liquid. These are both reducers, they're different ones, but they're both reducers, and just watch. So I'm going to tear the scale, so it weighs nothing. So we're weighing the cups as well, but the cups weigh the same, right? So I'm going to put this on, and you'll see that this volume of liquid, which is 1 pint exactly of liquid, is 423 grams of weight, right? And now this exact 1 pint of basically the same clear liquid weighs 548, like way more. So this is like liquid lead, and that's like liquid feathers, you know what I mean? So you can't use a mix stick, or you can't use the scale and the mix stick the same. They don't relate to each other. So this volume ratio of 1 to 2 for that recipe on there, the 236 to the 100, so the 100, that mix ratio of 100 grams of paint to 236 grams of the application adjustment binder is figured out by the computer, and the computer knows the specific gravities and the relation between the volume of the paint, so like the pint compared to its specific gravity, the weight, right? And weight and volume don't have any relation, right? And it's really like a lot of people don't know this, and there's painters out there that have been painting for 20, 30 years and they still screw this up all the time, right? And really the realistic difference to this is, which is crazy, is we looked at the tech sheet, and you can see we got low temperature and high temperature. That's what this is. This is low temperature thinner. This is high temperature thinner. So it's the same product, just with one number different, right? And look at the difference in weight. 400 and whatever, and 500 and whatever. 548, 423. There's like way more than 100 grams difference. So this is like 25% heavier. So if you mixed it the same by the scale, so by the weight, without using the computer to figure it out, so you just went, well, I got 100 grams of paint, I'm going to throw 200 grams of this stuff in, you would actually be screwing up that mix ratio, that 1 to 2, by 25%, and your paint could be like totally screwed. Like all kinds of weird stuff could happen. You could be over reduced or under reduced, or it would like solvent pop or run, or who the hell knows what, right? But just realize that this has nothing to do with that. If you don't have the computer figuring it out for you, you can't figure out this. You have to use the volume on the mix stick or the volume on the side of the cup, okay? Specific gravity, right? Specific gravity, heavy, specific gravity, light, and the only difference is what blend of reduction it is for how fast it flashes according to temperature, right? So you can't, you just have to realize this is the same. Look at these things are filled up exactly the same level. They both have exactly a pint in there, and they weigh totally different amounts. Okay, so just realize that that's not a thing. Now I'm going to mix up another color and show you guys how the pearls go in, which is kind of cool. Okay, so this is a goldy color. I chose, and it has a tiny little bit, 1.6 grams of 1014, which is ruddily red pearl, I guess. I don't know. It's 1014, right? And pearls can come in this form, which is just dry powder, or it can come in this form, which is liquid, right? And it depends on the mix system. This is our waterborne, this is our solvent. Our solvent has dry pearl. It's kind of old school, but yeah, that's so it's just a bunch of powder in there, right? And they're little glass beads that are tinted ruddily red. So this is kind of like a salt shaker. It has like a pory thing here, and it has a scoopy thing here. I don't use it. I just take it off, and I just use a mix stick. Some people use a spoon, but you could just use a mix stick. I find it works pretty well. And we need 1.6 grams. And one thing to realize, everything we've been putting in, 1.6 grams isn't very much, right? But it's because the liquid stuff, like this one here, is heavy. This thing weighs nothing because it's just like glass powder in here, or mica, I guess they're plastic. I don't know. The little beads, whatever it is just very, very lightweight. It's kind of like flour, right? So like I can't even feel that on the stick until I put like a shovel load on, right? So you just take some dry pearl like this, and we just slowly shake it in, and you'll see this much is not even a gram. That was on the end of that stick, right? So it doesn't weigh very much, so it looks ridiculous to be putting in 1.6 grams, but this dry pearl is very, very light, right? So it's 0.8, put that much more in, 0.1, and don't bang it on the cup because you don't want to upset the scale, right? So what you can do is just bang it against the container or something. So on 1.1, a little bit more, 1.2, 1.3, and just go little by little when you start to get close. 1.5 and 1.6, right? So that's how the pearl goes in. If you look at it, just the pile, and it looks very ugly when it's just dry like this until it goes in the liquid. Then it starts shimmering all of its fancy colors and doing all of its fancy stuff. And you can see my method for picking out. I over poured on this whatever that is, that ready magenta, whatever that is, stuff there, and I had to pick it out with the hook. I had to pick out quite a bit. I think that's like 0.4 grams or something like that, but I poured right in the middle, and you can see that's just the red. There's no like other color in it, right? So that's what that was. I screwed up when I wasn't recording, and I had to pull some back out, right? So that's how you put the pearl in, right? If it's liquid pearl, it's just like any other toner, but if it's the dry pearl, it's a little bit different. And the numbers are always really, really small, but it's actually quite a bit of pearl because this thing weighs like very little, right? You can see this whole container is only 150 grams, right? And like if you fill this cup up with liquid, it like that one reducer was like over 500 grams, right? So very, very light weight. And these dry pearls just sit down here on the mix system, right? In order. Okay, so yeah, that's basically how you mix paint. And then this thing, I just got to put all the clear stuff in and stir it up, and it's good to go too. And this one, well, maybe I'll do it just so you guys can see it. Maybe somebody's interested, I don't know. So we got to put 66B in, 66B. I'll put this one in and I hit 0 to show you the 1.6. So this is 29.2, 29.2. Try to get it right. No, I went over by 0.2, 0.5, whatever. Okay, so this is just test paint, so we'll pretend like I'm doing it very carefully and accurately and not trying to do it quickly so I don't bore you, okay? SBL 624B. I don't know why it needs the other one too. It's odd. Usually they just take one. This one wants two, whatever. And this one is 21.5, so we put 21.5. Sorry, you gotta watch these lids. Sometimes they're sticky. 21.3. And I went over again. Oh well. Okay, and then the last, oh no, wait, two more. 25B, which is up here. 25B of this one. And this one goes in for 8.4. Probably going to pour over again. Come on, easy. Easy. Don't pour over again. 8.4. Easy. Don't pour over. Don't pour over. Oh. Yeah, bang on, right? Okay, and then the last one, which is already over here, and this one goes in for 243. So you go like crazy, just let her rip. For 243. 243. Whoop. 43.4. Look at that. Okay, and then when we stir this one, oh, I don't want to use this stick. You gotta wipe this first, so it'll have extra pearl in there. Although this probably is like almost nothing because it weighs almost nothing. I'm gonna wipe it off anyways. We'll stir this up, and this like disgusting looking concoction of like burgundy goop should turn a bright gold. Look at that. See, it's gold. Beautiful. Sparkly, pearly gold. Right? Cool, eh? And a lot of these colors are like pretty exciting or pretty boring until you stir them, and you really have no idea what it's going to look like until you give it a stir, and then bam, you get a beautiful color out of a bunch of ugly soup, right? And all these little swirls and stuff, that's the liquid paint. You don't get the true color until it's sprayed. So the spraying sets all those sparkles correctly and evens out the color, right? So if you brushed it onto a car, it would be all streaky and brush marky like the way this cup looks, right? So it's why we have to spray it, and you can see how important those metallic angles are, and that's why it's so important to spray correctly and use good spray guns. Otherwise your paint job will look something like that too, right? That's the difference between good spraying and bad spraying, and good spray equipment and bad spray equipment is how it sets the metallics, right? And you can see on this mix stick, that's why you can't polish out a run in the base coat, right? Because all the metallics are flopping over where the run is. So if you get a run in your base, you fix it before you clear coat, because you're always going to see it through the clear coat, right? Because all those metallics are folding over and changing angles as to that paint, right? Pretty neat, eh? So this is like the real hardcore automotive paint. You can see this little tiny cup of paint is $44. It's 45 bucks, right, of base coat. And that's no primers, no clears, no nothing, no labor. That's literally just the stuff we poured into this cup is worth that much money. Okay, so that's mixing in a nutshell. You've seen a solid color, you've seen a metallic color. We could do waterborne, I guess, but it looks exactly the same. It's just a little thicker. It smells different. You can't smell through YouTube, so we're just gonna leave it at that. That's what you do. You go to the computer, look it up, print out the recipe, you weigh it all out, hopefully more accurately than I just did, and then you should have a very accurate match to the car, right? Yeah, so that's it.